Hello everyone. Hello everyone. My name is Asavari Anil Reddy from Sri Siddheshwar Women's College of Engineering, Solapur. I am the first year student of Computer Science and Engineering. Hello everyone. Welcome back to my channel. Today we are going to understand an important physics topic: different types of magnetic materials based on magnetic moments. Magnetic materials are classified based on how their atomic magnetic moments behave in the presence of a magnetic field. In this video, we will study 5 types of magnetic materials, their behavior, and real life examples in a very simple way. So, let's start from the basic. Now, what is magnetic moment? Every atom contains electrons, and these electrons rotate around the nucleus and also spin about their own axis. Due to this motion, each atom behaves like a tiny magnet, which we call a magnetic dipole. The way these tiny magnetic moments are arranged inside a magnetic material decides how that material behaves magnetically. Based on this alignment of magnetic moments, magnetic materials are classified into diamagnetic materials, paramagnetic materials, ferromagnetic materials, antiferromagnetic materials, ferrimagnetic materials. In the next slides, we will discuss each type one by one with clear explanation and examples. Let us understand with diamagnetic materials. In diamagnetic materials, atoms do not have permanent magnetic moments. This is because the electrons are paired and their magnetic effects cancel each other. When we apply an external magnetic field, these materials produce a very weak magnetic field in the opposite direction. Due to this, magnetic materials are weakly repelled by the magnetic field. One important point to remember is that diamagnetic materials are not attracted, they are repelled. Their magnetic susceptibility is negative, which means their magnetization opposes the applied magnetic field. Examples of diamagnetic materials include copper, bismuth, water, gold, silver. Diamagnetic is present in all materials, but in most cases it is very weak and gets hidden by other magnetic effects. Paramagnetic materials. Now let us talk about paramagnetic materials. In paramagnetic materials, atoms do have magnetic moments, but these moments are randomly oriented in the absence of a magnetic field. Because of this random orientation, the net magnetic moment becomes zero when no field is applied. When an external magnetic field is applied, these magnetic moments align slightly in the direction of the field. As a result, paramagnetic materials are weakly attracted by the magnetic field. However, once the magnetic field is removed, the alignment disappears and the material loses its magnetism. Paramagnetic materials have positive magnetic susceptibility, but its value is very small. Examples of paramagnetic materials are aluminium, platinum, oxygen, magnesium. So remember, diamagnetic is weakly repelled, paramagnetic is weakly attracted. Now we come to the most important and strong magnetic materials called ferromagnetic materials. In ferromagnetic materials, atomic magnetic moments are strong and permanent. These moments align parallel to each other even without an external magnetic field. The materials is divided into small regions called magnetic domains. Inside each domain, all magnetic moments are aligned in the same direction. When an external magnetic field is applied, these domains grow and align in one direction, resulting in very strong magnetization. This is why ferromagnetic materials are strongly attracted by magnetic field and can retain magnetism even after removing the field. This property is called retentivity, and it is the reason ferromagnetic materials are used to make permanent magnets. Ferromagnetic materials also show a phenomenon called hysteresis, which is very important in transformer and motors design. Common examples of ferromagnetic materials include iron, cobalt, nickel, electric motors. Applications of these materials are electric motors, transformers, magnetic storage devices, loudspeakers. Ferromagnetic is the strongest form of magnetization. Antiferromagnetic materials. Next we have antiferromagnetic materials. In these materials, atomic magnetic moments align in opposite directions, just like ferromagnetic materials, but with one key difference. Here, the magnitudes of the magnetic moments are equal and they cancel each other completely, so the net magnetic moment becomes zero. Because of this, antiferromagnetic materials do not show magnetism under the normal condition. Example of antiferromagnetic materials are manganese oxide, chromium. These materials are mainly studied for advanced magnetic applications and solid state physics. Now, ferrimagnetic materials. Finally, let us discuss ferrimagnetic materials. Ferrimagnetic materials are similar to antiferromagnetic materials, but here the magnitudes of magnetic moments are unequal. Although the magnetic moments are aligned in opposite directions, they do not cancel completely. As a result, ferromagnetic materials have a net magnetic moment. Examples of ferrimagnetic materials are ferrites, ferromagnetic materials are widely used in transformer cores, in inductors, microwave devices. So, in conclusion, to conclude, magnetic materials are classified based on alignment of atomic magnetic moments. Diamagnetic are weakly repelled, paramagnetic are weakly attracted, ferromagnetic are strongly magnetic, and antiferromagnetic are zero net magnetism, and ferrimagnetic have moderate magnetization. Understanding these materials is very important for physics and engineering applications. If you found this video helpful, please like, share, and subscribe to the channel. Thank you so much for watching. So, in this video, we have seen all the types of magnetic materials. Here, the one most important point I have to discuss, that is diamagnetic materials of uh, their magnetic susceptibility is negative, which means their magnetization opposes the applied magnetic field. So, important point to remember is that diamagnetic materials are not attracted; they are repelled. Diamagnetic materials examples are copper, bismuth, water, gold, silver. Diamagnetism is present in all materials. In most Now, the most important point is quickly revise what we have learned in today's video. We studied the magnetic materials are classified based on the behavior of atomic magnetic moments. These tiny magnetic moments inside atoms decide whether a material will be attracted, repelled, or strongly magnetized. First, we learned about diamagnetic materials, and these examples are copper, water, show that not all our materials are attracted to magnets. Now, to conclude, the alignment and interaction of magnetic moments is the key factor that decides the magnetic nature of a material. This concept is very important not only in physics. Examples but also in real life applications like motors, generators, memory devices, and communication systems. I hope this video helped you understand the topic in a simple and clear way. If you found this explanation useful, please like this video, share it with your friends, and subscribe to the channel for more educational content. Thank you so much for watching. See you in the next video.